Radiopharmacy Calculations. Decay calculation using a half-life. Calculate activity using a half-life. Activity of time is equal to activity of the original times e to the negative 0.693 times the elapsed time over half-life. A vial of DTPA is reconstituted with 200 millicuries of technetium-99m. What will its activity be at 3 hours later? The activity of time is equal to 200 millicuries times e with the negative 0.693 exponent times 3 hours over 6.01 hours is equal to 142 millicuries. Decay calculations using decay charts. Calculate activity using a decay factor. Calculate the time elapsed. Refer to the appropriate decay table and select decay factor. Use equation A of time is equal to the A original times the decay factor. Decay factor 4 times that exceed those listed on a table. Multiply factors together for times that add up to a total time. Example, a vial of technetium-99m sodium pertechnetate contains 572 millicuries at 8 a.m. What is the activity at 12:30 p.m.? The decay factor, must have looked up in the chart, is 0.595. So you have 572 millicuries times 0.595 equals 340 millicuries. Pre-calibration calculations. Calculate activity using a pre-calibration factor. Calculate the elapsed time between the prep and the calibration. Refer to appropriate decay table and select pre-calibration factor. Apply the equation. Activity of the original is equal to the activity of time times the pre-calibration factor. Calculate activity using a decay factor as a pre-calibration factor. Calculate the elapsed time between prep and calibration. Refer to appropriate decay table and select decay factor. Apply the equation. Activity of time is equal to the activity of the original times the pre-calibration factor. Calculate pre-calibration factors that exceed the times listed on a table. Multiply factors together for times that add up to total time. A 22 millicurie technetium-99m HTP unit dose is needed for 10 a.m. The dose is being prepared at 6 a.m. How many millicuries must be placed in the syringe? There's two ways to solve this. The pre-calibration factor method, which you calculate the elapsed time between preparation and calibration times is 4 hours. Select the pre-calibration factor from the technetium-99m table in the appendix, which is 1.587. So you take the 22 millicuries and multiply that times 1.587, you get 35 millicuries. Option 2 is the post-calibration decay factor method. Calculate the elapsed time between preparation and calibration time. It's 4 hours. Select the decay factor from the technetium-99m table, which is 0.693, and then you'll take the 22 millicuries and divide it by the 0.63, which is equal to 35 millicuries. If the 4-hour pre-calibration factor for technetium-99 is 1.587 and the 5-hour pre-calibration factor is 1.779, what is the 9-hour calibration factor? To get this, we take the 4 hours plus the 5 hours to get 9 hours. And then you're going to multiply the two together. So you'll have the 1.587 times the 1.779 is equal to 2.823. So the 9-hour decay factor will be 2.823. The specific concentration is equal to activity over volume. A vial contains 35 millicuries of thallus 201, thallium 201 thallus chloride in 4.2 milliliters. What is the concentration? 35 millicuries divided by 4.2 milliliters is equal to 8.3 millicuries per ml. Calculate the volume required to provide a desired activity required. The required volume is equal to the activity of the desired millicurie over the specific concentration in millicuries per ml. A vial of technetium-99m sodium pertechnetate contains 375 millicuries in 8.2 ml. If 20 millicurie dose is needed, how many mLs must be withdrawn from the vial? Calculate the concentration, which is 375 millicuries by 8.2 ml, is going to equal to 45 millicuries per ml. Then you calculate the required volume. So 20 millicuries is divided by 45 millicuries per ml is equal to 0.4 ml. Total activity needed to provide a specific number of kits or doses uses pre-calibration factors. The total activity required is equal to the sum of the dose times pre-calibration. The activity needed to provide a specific number of kits or doses using decay factors. The total activity required is the sum of the dose divided by the decay factor. An MDP kit is being reconstituted to provide one 20 millicurie dose at 9 a.m., at 10 a.m., and at 11 a.m. and at noon. What is the minimum activity that must be placed in the vial when it is being prepared at 7 a.m.? It gives the example on page 167. It answers 121. So what you're going to do is you're going to take the 20 millicuries into 4 separate decays, and you're going to need to positively decay it. So it's going to be 20 millicuries times e to the positive 0.693 times whatever the time difference would be. If it starts at 7 a.m. and it's at 9 a.m., that'll be 2 hours. So you'll do a 2 hour, 3 hour, 4 hour, and a 5 hour decay factor. And since you need more than the 20, you're going to do the 9 a.m. one, so it'll be 20 millicuries E with the exponent of positive 0.693 times 2 divided by 6. The 6 is the half-life of the technetium, and that'll give you the 1. So you're going to have to do it 4 different times, and then after you're done, you'll add all 4 of your final doses out, and then that's how you get the 121 millicuries. Determine TV to be added to a kit with volume limits. TV equals total volume. Calculate specific activity. Calculate the volume to be added. Compare the volume to the manufacturer's range. Dilute eluate if minimum volume is not met. The minimum volume diluent to be added is equal to the minimum kit volume minus the calculated kit volume. Prepare the kit for fewer doses if the maximum volume will be exceeded. The package insert for technetium-99m labeled radiopharmaceutical kit recommends 1 to 5 ml volume. The technologist plans to reconstitute the kit with 30 millicuries of eluate. The eluate contains 150 millicuries in 2 ml. Determine the volume to be added. If it fails to meet the manufacturer's recommended minimum, determine the volume of physiological saline that must be added. So we have 150 millicuries divided by 2 ml. It's going to give us the concentration of 75 millicuries per ml. And then we take the 30 millicuries and divide that by that concentration of 75 millicuries per ml is equal to 0.4 ml. So calculate the minimum volume of saline to be added. The minimum amount that we need is 1 ml. So 1 ml minus 0.4 is equal to 0.6 ml. You'll need 0.6 ml of the saline. To calculate the total volume, continued. Determine the total volume to be added to a kit with activity limits. Determine the total activity needed using pre-calibration or decay factors. Sum the doses, compare the volume to the manufacturer's range, add activity if the minimum is not met. Prepare the kit for fewer doses if the maximum activity will be exceeded. Example, according to the package insert, a particular MDP kit should be reconstituted with a maximum of 200 millicuries of eluate. If 3 20 millicurie doses are needed at 9 a.m. and 3 more are needed at 11 a.m., will the activity limit be exceeded when the kit is prepared at 7 a.m.? The 9 a.m. doses use the 2-hour pre-calibration factor, so you have 1.259. So 3 times 20 times 1.259 is equal to 76 millicuries. At 11 a.m. doses use the 4-hour pre-calibration factor, so 1.587. So 3 times 20 times 1.587 is equal to 95 millicuries. So you're going to add up the 76 plus the 95 millicuries. That's going to equal to 171 millicuries. So your answer is no, because the activity will not be exceeded. Dose calculation based on activity per unit weight. The patient dose. The dose in kilograms multiplied times the patient's weight in kilograms. A 35 kilogram pediatric patient is scheduled for Meckel scan. The protocol requires technetium 99M per technicate. Dose of 75 microcuries per kilogram. What dose should be administered? So it's 75 microcuries per kilogram, and there's 35 kilograms. You multiply 75 by 35, you're going to get 2,625 microcuries, or 2.6 millicuries. Unit dose adjustment. Calculate the current concentration. If used prior to calibration time, the current concentration is equal to the calibrated activity times the pre-calibrated factor divided by the volume in syringe. If used after calibration time, the current concentration is equal to the calibrated activity times the decay factor divided by the volume in syringe. Number 2, calculate the volume to be retained in the syringe. The volume to be retained in the syringe is the desired dose divided by the current concentration. Calculate the volume to be discarded, so only the desired dose remains in the syringe. To do that, the volume to be discarded is the actual volume minus the volume to be retained. An example. A unit dose of technetium 99M sodium pertechnetate was calibrated for 9:30 a.m. to contain 3 millicuries and 1.8 ml. At 11 a.m., it is to be used at as a 2 millicurie dose. How many ml must be discarded? Solution. Calculate the current concentration. The decay factor for 1.5 hours for technetium 99M is 0.841. So you're going to take 3 millicuries, multiply it by the 0.841 decay factor, and then divide that by the 8.1. So you're going to end up with 1.4 millicuries per ml. Calculate the volume to be administered. The volume be retained in the syringe. 20 millicuries divided by 1.4 millicurie per ml. So 1.4 ml to be retained. Calculate the volume to be discarded from the syringe. 1.8 is the actual volume minus the 1.4 to be retained. You're going to have the 0.4 ml to be discarded. Using the Clark's formula for the pediatric dose, it is child's dose is equal to the child's weight in pounds multiplied by the adult dose and then divided by 150. A 40-pound child needs a bone scan. What should be given to the dose? So you're going to take the 40, multiply it by the 20, and then divide that by the 150. You'll end up with a 5 millicurie dose. Now, using the body surface area, you're going to calculate the fraction of the adult dose to be used. Fraction of the adult dose is equal to the body weight in kilograms with a 0.7 exponent. Then you divide that by 1957. So 19.57. So the body weight in kilograms with the 0.7 kilogram divided by 19.57. Calculate the child's dose. This is the pediatric dose. This is the adult dose times the fraction of the adult dose. So if a 4 millicurie dose of technetium-99m MAA is given to an adult, how much should be administered to a 24 kilogram child? So you take the 24 and you figure the amount with a 0.7 exponent. You get the 9.25, and then you're going to divide that by the 19.57, which is equal to 0.47. So then you take the 4 millicuries for the adult dose and multiply that by the 0.47, and you're going to end up with 1.9 millicuries for the child dose. Pediatric dose calculations using Talbot's nomogram. Using a straight edge to read the patient's body weight on the bottom of the line to the arching line that crosses the table diagonally. Now read from the arching line to the percentage of the adult dose on the right-hand side of the table, changing the whole number to a decimal to apply it to the calculation. The pediatric dose is equal to the fraction of adult dose times the adult dose. A 20-pound child needs a hepatobiliary scan. If the adult dose is 10 millicuries, how many millicuries should the child receive? Need to look at the page on the Talbot's. According to Talbot's nomogram, the child should receive 26% of the adult dose. So 0.26 times the 10 millicuries of the adult dose is equal to 2.6 millicuries. The minimum and the maximum pediatric doses. Determine the pediatric dose using one of the pediatric determination methods. Compare the calculated dose to the minimum and maximum dose list. If the calculated dose is smaller, the minimum dose must be used. If calculated dose is larger than the maximum dose is to be used. Use the BSA table to solve. The adult dose for technetium-99m HMPAO brain imaging is 10 millicuries. What dose would be given to a 6 kilogram infant if the minimum dose is 2 millicuries? Using the BSA table, determine that the fraction of the adult dose to be used is 0.18, so calculate the dose. The 0.18 times 10 millicuries is equal to 1.8 millicuries. Since 1.8 millicuries is below the minimum dose of 2 millicuries, the minimum dose should be used. Lung perfusion and radiopharmaceutical particle calculations. Determine the volume dose to be administered to the patient. The specific concentration is equal to the activity divided by the volume. The required volume is equal to the activity desired in millicuries divided by the specific concentration in millicuries per ml. 2. Calculate the particle concentration of the reconstituted kit. Particles per ml is equal to total particles in kit divided by ml added to the kit. 3. To calculate the particles per dose, direct proportion is particles divided by 1 ml is equal to particles in patient dose divided by ml of patient dose. Example of particle calculation. An MAA kit produced by company XYZ contains an average of 4 million particles. If the kit is reconstituted with 5 ml, what is the particle concentration? So you take the 4 million particles divided by 5 ml, and you're going to equal 800,000 particles per ml. Generator efficiency, the elution efficiency. Actual yield divided by the theoretical yield times 100. The actual yield is technetium-99 removed during elution. The theoretical yield is technetium-99 present on the column. If the Molytech generator contains 820 millicuries of technetium-99, but only 688 can be eluted, what is the efficiency? You're going to divide 820 by 680. Yep, 680 divided by 820 times 100 is 83% efficiency. So estimate the generator yield based on theoretical yield and elution efficiency. The generator yield is the estimated yield is equal to theoretical yield times the elution efficiency as a decimal. If a generator regularly yield 85% of technetium-99m activity on its column, how many millicuries will be eluted when 710 millicuries are present on the column? So you convert the 85 to decimal form, which is 0.85. So you take the 710 and multiply that by 0.85, and you'll get your 604 millicuries. Moly detect generator yield based on decay. Theoretical yield of Moly detect generator at a specific time post-elution. Calculate the elapsed time from the last elution and select appropriate Moly 99 decay factor. Select the technetium 99 Moly fraction for elapsed time. Activity of 2 divided by activity of 1 is equal to, I'm not doing whatever that nonsense is. Determine the theoretical yield of technetium 99 for specific Moly activity times the decay factor multiplied by the technetium to Moly 99 ratio as a fraction. A generator calibrated for 4100 millicuries of Moly at noon on Wednesday is to be eluted at 8 a.m. on Thursday. Assuming the generator was last eluted at calibration time, what is the theoretical yield of technetium 99M at 8 a.m.? Calculate the time between elution hours, which is 20 hours. You select the decay factor for Moly from the appendix, which is 0.812. So you take the 4100 millicuries and you multiply it by 0.812, and then you're going to multiply that by the 0.830. You'll get 2,763 millicuries of tech. Estimated yield. To get the estimated yield, you have the Moly activity times the decay factor, and then the tech to Moly ratio fraction times the efficiency. Use Moly's half-life and decay factor calculation. Look up the ratio on page 196. A generator column containing 522 millicuries of Moly was eluted at 2 p.m. It is eluted again at 10 p.m. Estimate the yield if the generator has an 85% efficiency. The elapsed time is 8 hours. The Moly decay factor is 0.911, and the tech to Moly fraction is 0.537. So you take the 522 millicuries and multiply that by 0.911. And then you'll multiply that by the fraction, which is 0.537. And then you do the efficiency, which is 0.85. You'll get 217 millicuries. Allowable Moly content in the generator eluate. Moly limit for particular activity of technetium 99M x microcurie of Moly 99 is equal to 0.15 microcurie Moly to millicurie technetium 99M. Activity of tech multiplied by the activity of technetium 99M in millicurie. The specific concentration of Moly 99 x microcurie of Moly divided by the millicuries of tech per mm is equal to activity of Moly 99 in microcuries over the activity of technetium 99M in millicuries. A vial of a generator eluate contains 450 millicuries of technetium 99M. What is the maximum activity of Moly 99 allowed for this activity? .15 microcuries of Moly divided by per millicurie of technetium 99M is multiplied by 450 millicuries of technetium 99. So you're going to get 67.5 microcuries of Moly. Example of specific concentration. What is the concentration of Moly 99 in a vial containing 310 millicuries of technetium 99M and 20 millicuries of Moly? Is it within the NRC limits? So you're going to divide the 20 microcuries by the 310 millicuries, and you'll get a 0.6 microcuries per millicurie of tech. Since 0.06 microcuries is less than the 0.15 microcurie limit, the eluate can be used on patients. Eluate expiration time based on Moly content. The time is equal to negative ln times the initial Moly activity over the tech activity. And you take that equation and you divide that by 0.105, and then you're going to subtract 18.03 from the final. So at the time of the elution, a vial contains 150 millicuries of technetium 99M and 18.3 microcuries of Moly. Determine when the eluate will exceed the NRC limits. So the time it would take for it to exceed, you take the negative ln and you multiply that by the 18.3 divided by 150. After you get that, you will divide that total by 0.1052 and subtract 18.03 from the final. You'll end up with 1.97 hours. That's the end.